Class of 2026, the Kjsea, welcome back again to revision 2. We are still revising, we are still doing revision for Kjsea 2026 as you prepare yourself to sit for the final exam in the October. Now, I have a question here on my whiteboard. You'll allow me to read, and after reading, we'll have time to answer it together. So, in an experiment, so this is an experiment that was being done in the laboratory. In an experiment, grade 8 learners poured some water in a beaker. In an experiment, grade 8 learners poured some water in a beaker and dropped ink in the water. The first question, what observation did the learners make? Then the second observation, which process were the learners demonstrating? Then the last part of that question, state and explain two factors that affects the process named above. Two factors that affects the process named above. Now, let me also read what we have on the whiteboard here. In an experiment, grade 8 learners poured some water in a beaker. They poured some water in a beaker and dropped ink in water. Right? Then the question number 1, what observation did the learners make? I remember I said this. When we are talking about observation, we are talking about those things which you are able to see with your eyes, with your sense of sight. Those things that you are able to detect with your sense of sight, particularly eyes. Whenever you meet a question in integrated science, it is asking you to state the observation. In a simple term, the questions wants you to state what you are able to see. So for this case, after the learners has poured water in a beaker, then after a short while they added an ink, these learners were able to see a uniform solution, or they observed a uniform color. They observed a uniform color in the beaker, or color in the beaker, a uniform color in the beaker. So these learners observed a uniform color in the beaker, or a uniform solution in the beaker, depending on the color of the ink. For instance, if the ink was purple in color, they will be able to observe a uniform pink solution in the beaker, or a uniform pink color in the beaker. So they were able to see the color with their eyes. Now question B, which process were the learners demonstrating? Which process were the learners demonstrating? B, which process were the learners demonstrating? I want you to engage your mind and try to figure out the process that was being investigated here. Very simple. So these learners were demonstrating diffusion. These learners were demonstrating diffusion. Right? Why are we saying that these learners were demonstrating diffusion? And we need to understand, we need to know what is diffusion. Right? How do we define diffusion? Diffusion is the process by which particles or molecules move from a region where they are highly concentrated to a region where they are less concentrated. Right? Now, when we come back to the statement, the first statement here, they first poured some water in a beaker. Then they dropped some ink in that water. Then you come to our observation. These learners were able to observe a uniform solution, or a uniform color in the beaker. Right? To mean the color of ink has spread through the water. The color of ink has spread through the water. Right? The color of ink has moved from a region where they are highly concentrated at the bottom of the beaker to other parts in the beaker where they are less concentrated. That's why we are able to see a uniform color in the entire beaker. That's why we are able to see a uniform solution in the beaker, because the particles of the ink have moved from where they are highly concentrated at the bottom of the beaker to other parts of the beaker, right? So the process which is being demonstrated here is diffusion. Don't forget. Then we have part B. Part C, I mean question C. State and explain two factors that affect the process named above. Now the process named above is diffusion. What are the factors that affect diffusion? Very simple. We talked about the factors that affect diffusion when we were talking about the movement of particles in and out of the cell, right? Remember we said that we only have two processes in which materials are able to move in and out of the cell. And these two processes are diffusion and osmosis. And these are biological processes that aid in the movement of particles in and out of the cell. We have diffusion and osmosis. Now, just to remind ourselves, what are the sum of the factors that affects diffusion? Number one, we have temperature. Number two, what do we have? We have surface area to volume ratio. Surface area to volume ratio. We have surface area to volume ratio. C, we have the thickness of the membrane. Thickness of the membrane. The thickness of the membrane. 3, we have 8. 4, we have the size of the particle. The size of the particle. 4, we have, remind me, apart from temperature, surface area to volume ratio, the thickness of the membrane, the size of the particle, the medium, the number 5, remind me. So we have temperature, surface area to volume ratio, the thickness of the membrane, the size of the particle, then the medium. When we talk about the medium, we are talking three states of matter. We're talking about the 3 states of matter. We have solid, liquid, and gases. Solid, liquid, and gases. So let me see if I'm forgetting another factor. We have temperature, surface area to volume ratio. We have the thickness of the membrane. We have the size of the particle. Then we have the medium. These are just some of the factors that affects the diffusion. Now we want to see, how does temperature affect the diffusion? How does the temperature affect the diffusion? Let me use this example. You will be able to detect the scent of a perfume during a hot sunny day compared to very chill in the morning. You'll be able to detect a bad smell from a decaying road along the path during the day, where the sun is at the top, where the sun is hot, than very early in the morning. Reason? Remember, we are still talking about temperature. So this is how we say an increase in temperature increases the rate of diffusion. So when you increase the temperature, the rate of diffusion increases. The movement of particles from A region where they are highly concentrated to a region where they are less concentrated increases. Now you need to ask yourself a question. Why is it that when you increase the temperature, you increases the rate of diffusion? I'm giving you time to figure out. This is what happens. When you increase the temperature increases the energy of the particles, or the kinetic energy of the particles. Therefore, the particles will spread more faster, or the particles will move more faster. That's how the temperature increases the rate of diffusion. As you increase the temperature increases the kinetic energy of the particles. Hence, the particles move more faster compared when the temperature is low. How does the surface area to volume ratio affects the rate of diffusion? Size of the particle, the surface area to volume ratio. An increase in surface area to volume ratio increases the rate of diffusion. This explains why diffusion is faster in small organisms compared to large organisms. The thickness of the membrane. How does the thickness of the membrane affects the rate of diffusion? The thicker the membrane, the slower the rate of diffusion. The thinner the membrane, the faster the rate of diffusion. The thicker the membrane increases the distance to be covered by diffusing particles. That's why leading to a decrease in the rate of diffusion. The thinner the membrane, the particles are able to diffuse within a short distance, right? So the thickness of the membrane, the thicker the membrane, the slower the rate of diffusion. I mean, the thin the membrane, the faster the rate of diffusion. The thicker the membrane, the slower the rate of diffusion. The size of the particles. Size of the particles. How does the size of particles affect the rate of diffusion? Very simple. Large and heavy particles diffuse slower than small and light particles. If you have large particles, large in terms of weight, and big particles, they take a lot of time to diffuse compared to when you have small and light particles. So we therefore say light and small particles diffuse faster than large and heavy particles. Then medium, type of medium. When we are talking about medium, we are talking about the three states of matter. In this case, we are talking about the solid, the liquid, and the gases. How does it affect the rate of diffusion? Diffusion is faster in gases than in liquid, than in solid. The reason why diffusion is faster in gases than liquids, the particles in gases are far apart from one another, right? Or the kinetic energy in the particles of gases is higher than the kinetic energy in the particles of liquids. So the particles in gases are able to move more faster than the particles in liquid. At our level here, diffusion does not take place in solids.